So we'll go back to our main menu. We're going to open up a new static structural analysis. And we're going to share the material properties. So I'm going to click here on engineering data, and I'm going to drag it over here to the engineering data. And we're also going to share the geometry. So what I'm going to do is I'm going to go over here and drag geometry from the A to the B. And we're going to right click. I'll have to close the old design modeler first. Close out of that. Now we'll go back to our main menu. We're going to right click. Oh, I'm sorry. Because we shared, you can only edit it in the A. So actually what I'm going to do is now that we've shared the geometry, it should copy it over. I'm going to click on this link and click delete. And now we should be able to click edit geometry. And we see that the geometry has been copied over. So the next thing I'm going to do is I'm going to suppress the two bodies that we don't need. So I'll select, you can hit control, and then with the body filter selection on, you can select both and then right click. And we're going to click suppress body. Now, the next step, what we're going to do is we're going to take our results and we're going to drag them, or our solution rather. So I'll click on solution and drag it over to our setup. So what that's telling ANSYS is that you want to share the displacement results from your global model to your submodel. And then we're going to right click edit. And now we see our submodel of the notch. So we're going to make sure that our solid, or we're going to go in here, geometry, and click solid, and then make sure our material assignment is aluminum alloy. Because if you don't match the materials, you won't get the right results. So go in here and right click mesh. We're going to mesh this. We're going to right click mesh, insert, sizing, and then click our submodel. And we'll change this to 0.1. And we'll click mesh. All right, so let's just check our mesh statistics. So we're a little high on the mesh count, so we need to actually, we'll decrease this. ANSYS student license limits you on your mesh count. And it's still a little high. All right. So in this next part, I'm going to show you how to apply or do the submodeling and apply the boundary conditions. So if you go here, when you go into ANSYS and you share your solution with the setup, you'll see this folder populates under the static structural, and it says submodeling. So in order to set up submodeling, we're going to right click and we're going to insert a cut boundary constraint. Now, when you do that, you're going to see this tab open up, and there's some selections that you have to make. So we're going to click on the top face, click apply, and you'll see that it says tabular loading program controlled. So there's different, you can map the results from different, um, you can go in here and change this, and you can also map the results from your different source times. So over here it says end time. That's what we want. So if you did like a transient analysis or you had multiple load points over time, you can map individual results from those load points. And our source bodies we're going to leave to all. Now you can actually change this to manual. And if you know the manual IDs, let's say you just wanted the map from a specific body to the submodel, you can go in here and change this. And so what I like to do is I like to come in here and graphics and click display source points on. Now you're going to see when you click display source points on, you're going to see the nodes from the global model. And this is a good way to check and make sure that your submodel is in the same coordinate system as your global model. Because you not only want it to be in the same coordinate system, but you want the submodel to align with the position of the global model. So we can see here that since we made our submodel from the global model, it lines up nicely. Now there may be an instance where someone makes a submodel and it's not directly from the global model. You're going to need to make sure that this lines up in the coordinate system. And so if we go back to manual control, so our source bodies, we're going to change that to manual. Now you have to know the material IDs to do this, but sometimes what I do is I go through one at a time, and you can you can see which bodies correspond to the material IDs. So for the top, so I guess to do this really rigorously, we'll map the top cut boundary from the top uh, mesh that's associated with that material ID, and then you can actually see here in the window. Now there's other controls for how you can map. You can click manual. You can change the weighting and the transfer type. I won't get into that here, but essentially the mapping of the displacements from your global model to your submodel is done from the shape functions of the actual elements. So essentially what you have to do is interpolate the displacements from your global model to your submodel. But that looks good. So then we'll right click import load, and you'll actually see the graphic of the map displacements. Now we're going to do the same thing for the bottom boundary condition. We're going to go in here and insert cut boundary constraint, click down the bottom, Click apply. Again, we'll change our source bodies to manual, and we remember from the first part of this, the material ID was 3, and we will display our source points. Now you can also display the source point IDs, which I believe they added into ANSYS. So that would be the nodal. I believe those are the actual individual nodal numbers. We'll just keep that to off. Now there's ways that you can align the mesh from the global to your submodel using these transformations. But again, the most rigorous way that I know to do it is to make sure that your submodel is in the same coordinate system and using the same coordinate system name and in the same position relative to the global model. We'll click import load. And again, we see the map displacements. Now we'll go in here and set up our stress. So click insert stress max principal, and then we'll look at the normal stress in the Y direction because it's a tensile load. And we will right click and click solve. Yeah, and you see that the stress uh, you can convert now you can converge your stress from the submodel. So if you had to, you could refine this mesh again to make it smaller. Just if you look at from our previous video, with the 300-pound load, the KT was about 3. So this looks like a pretty good result. And then again, if we look at the normal stress, now I'll do another video on stress convergence, but essentially what you can do is you can keep refining the mesh and plot the max stress as a function of your mesh refinement in the area of concern. And when that reaches an asymptote, you've converged your stress. But yeah, this is essentially how you submodel in ANSYS. And maybe I'll make some more advanced videos on all of these features of your cut boundaries. But hopefully you guys enjoyed the video and appreciate you watching. And I'm looking forward to making more videos. Thanks.